Okay, so quinoline and isoquinoline, the way that their protonation works is their quinoline and isoquinoline, the analogy is between benzene and naphthalene. So quinoline. So quinoline, isoquinoline protonation. The analogy is benzene and naphthalene. So as benzene is to naphthalene, so pyridine is to quinoline and isoquinoline. So pyridine is to quinoline and isoquinoline. And if we draw the orbital picture of quinoline, we're going to find so if I'm drawing in the skeleton of quinoline, I'm drawing this on its side, kind of. So if this is all in one plane, then there's going to be a pi system, which is 90 degrees to that plane. So all those pi orbitals, so these are those double bonds. Remember, they're all conjugated and aromatic. So we have this aromatic system of pi bonds that's going on. That's 90 degrees to the plane of the molecules. So this system, drawing it in there, it's 90 degrees to the plane. That's a little 90-degree angle symbol, that square there. And then the nitrogen lone pair, I've drawn it kind of exaggerated. The nitrogen lone pair is in this same plane. That's the nitrogen lone pair, and that's in this plane. And so this nitrogen lone pair is not involved in the conjugated system. So that means that nitrogen lone pair is more basic, and also that this is an electron poor system. So I'll write that on here. So the lone pair is in an sp2 orbital not involved in pi bonding. And that means these can be pronated fairly easily. They can act as bases. Because that lone pair, it isn't going to affect its aromaticity, they can act as bases. So, for example, the quinoline, protonated quinoline has a pKa of 5.94. 4.94, and protonated isoquinoline has a pKa of 5.4. And compare that with pyridine. So pyridine is about 5 as well. So all these molecules have similar pKa's. And that's because that lone pair on that nitrogen is not involved in the aromatic system, so it can actually act as